Hey you guys, so in this last video for 2.5, we're going to take a look at a few special cases of compound inequalities. So these are the or and the and problems, but the answers are going to be a little unexpected this time. Okay, so let's take a look at this first one. I've got negative 1/3 x is greater than negative 4, so to solve that one, I'm going to multiply by negative 3 on both sides. Okay, the goal there is I'm going to cancel the 3's out and also the negatives. Okay, so I get x is less than, I have to switch the sign, positive 12. Alright, I multiplied by a negative, so I have to switch the sign. Or, and then on this side, let's just add 3 to both sides. I get 10x is less than 50. Divide by 10. I get x is less than 5. Okay. So, in this problem, my inequality solution is x is less than 12 or x is less than 5. Okay? So, thinking about that, it's saying that x is smaller than the number 12 or x is smaller than the number 5. Interesting. So, let's do a number line and a truth table. Alright, so on my number line here, I'm going to put my two key numbers for my tick marks, 5 and 12. And on my truth table, x, TV here. Okay, so I'm picking my three sections here. On the left, I have 4. And then I tick mark is 5. In the middle, I could go with anything there. I'll go with 8. And then I have 12, my other tick mark. And bigger than 12 is 13. Okay, so there are my 5 numbers to test. Right? It's an OR problem, so I only need to go 1 for 2. I need to make at least one true. So for number 4, okay, for the number 4, 4 is less than 12. So already that's true. Once I get 1, I'm done. Okay, 5, well 5 is less than 12, so that's true. Okay, all I'm doing is starting to plug into this one. 4 was less than 12, 5 was less than 12, 8 is going to be less than 12. So I do 8 is true also. 12. 12 is not less than 12. 12 is not less than 5. So 12 is my first false, which means 13 is also going to be false because 13 is not less than 12 or less than 5. Okay. So this truth table, my 4, 5, and 8 were true. So I'll go true here on the tick mark and in the middle. And then 12 was false and 13 was false. Which leads me to a filled-in circle at 5, an open circle at 12, and then I can shade the middle section and the left. So really, I've shaded all the way from 12 all the way left. Okay, so when I do my interval notation, okay, I know I have a filled-in circle at 5, but because it's shaded on both sides of it, I don't have to like write an interval for 5. This is just one big shaded section. So I'm going to go from negative infinity on the left, comma, all the way up until 12. 12 is an open circle, so it's a parenthesis. Okay, so there's my interval notation answer and my number line. Okay. So this one's interesting. It's an OR problem, but it didn't go out in both directions. It actually just went to the left, all right? So this is the problem. This is those ones I was talking about where the truth table really helps you get the right answer for your shaded number line. Okay, let's try another. This one is an AND problem. So let's simplify both of these equations here. So for the left inequality, I have 2x. I have to distribute here, so it's minus 3x minus 3. Careful, you got to do negative 3 times 1 is negative 3 is greater than 5. I have like terms. 2x minus 3x is negative x minus 3 is greater than 5. Add 3 to both sides. Negative x is greater than 8. And then I have to divide by negative 1. So I get x is less than, I switch the sign, negative 8. X is less than negative 8, and then I go solve this one. This one's much easier. Subtract 1 from both sides. I get 2x is greater than or equal to 6. Divide by 2, x is greater than or equal to 3. So my final inequality, and I got to put that word "and" there, to x is less than negative 8 and x is greater than or equal to 3. Okay, there's the inequality. Number line time, I'll put negative 8, and I'll put 3, and I'll make my truth table. Okay, so let's look at this. X is less than negative 8, and x is bigger than 3. So my numbers, left section, negative 9, tick mark, negative 8, middle, 0, tick mark, 3, right side is 4. Remember, if I go too quickly, hit pause, catch up, and then start watching again. Okay. Now let's test these out. It's and, so I have to go 2 for 2, right? It has to be both of them that are true. So when I plug in negative 9 less than negative 8, that's true. Is negative 9 bigger than 3? No, that's false. So in my first one here, I get false. Then plug in negative 8. Negative 8 less than negative 8. No, that's not true. So that's going to be false already, because as soon as I get one false, I know I'm not going to go perfect. I'm not going to go 2 for 2. All right, well, let's see. 0. 0 is not less than 8. Or, sorry, excuse me, let me say that again. 0 is not less than negative 8, so that's false. And wait, 3 is not going to be less than negative 8, so that's false. And 4 is not less than negative 8, so that's false. So we got falses for everything, which means, hopefully you're thinking, no solution, right? If I get falses everywhere, like I could have open circles at those numbers if I wanted, but I'm not going to shade anything. It's false, 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 which means no solution, okay? And my interval notation, I do my no solution symbol, okay? And one thing I want to point out, if you think about this, this is saying I need a number that is both less than negative 8 and bigger than 3. That doesn't exist. There's no number that's smaller than negative 8 and at the same time it's bigger than 3. Okay? That's why this one turns out to be no solution, because there's nowhere where this overlaps. All right, one more. This one looks a little funny. Okay, you might have seen this in the book problems already. Right? This is a different way of writing an and problem, okay? Because and often represents in between, we have 5x plus 4 is greater than or equal to 9, and 5x plus 4 is less than 24. So when you see one that's written like this, it's kind of a triple, like a combined inequality. This is an and problem. All right, so when we solve it, right, I can solve it all in one step here, or all in one kind of process. When I want to get x alone, I want to get it alone in the middle. So I'm going to subtract 4 in the middle, but then I have to subtract 4 from 24. I also have to subtract 4 from 9. So I subtract 4 from all 3 spots, the left, the middle, and the right. They cancel out in the middle. I get 5 is less than or equal to 5x, which is less than 20. To get 5 alone, now I have to divide by 5, and that'll get the x alone. That'll get the x alone. So I divide everything by 5, all 3 parts, and I get 1 is less than or equal to x is less than 4. Okay? And you can kind of look at this as 2 pieces here. There's this inequality, which is saying x is bigger than or equal to 1, and then there's this second inequality, which is saying x is smaller than 4. Right? That's what makes it an and problem, because it's both of these things happening at the same time. So on my number line, I go 1 and 4. Truth table, x, TV, 0, 1, 3, 4, 5. Right? I just went left to right along the number line. Okay? Testing to make sure I get both. I have to make both true. Let's see. So 0. So when I plug 0 in here, we have 1 is less than or equal to 0 is less than 4. That 0 doesn't fit. 0 is not bigger than or equal to 1. That part's not true, so I get false. Okay. When I plug in 1, now, if I were to like erase this here, and let's try this again, I'd get 1 is less than or equal to 1, which is less than 4. That's true. That fits there. 1 is greater than or equal to 1. Okay, so that's true. If I change that right there, if I change that to 3, it fits. Okay, 3 is between 1 and 4, so that works, so that's true. But as soon as I change it to a 4, alright, when I change this to a 4, I don't like this eraser. When I change that to a 4, now it doesn't fit, because 4 is not less than 4. So it's false. 5 won't fit in there either, that's false. So I've got my false, true, true, false, false. So I fill in that circle, open circle at 4, shade the true in the middle, okay? And then my interval notation is going to be bracket 1, comma 4 parenthesis, because I have a filled in circle at 1 and an open circle at 4. Okay, so those are three more practice problems there. You got a ton of practice problems in your binder. Those would be good to try. The more problems you practice, the better at these you'll get. Okay, thank you guys.